Hi guys, good afternoon everyone. Anyone can confirm that I'm audible? Sorry, hello. Hi, okay, thank you, Samir. Thank you guys. Thank you. Thank you, Aditya.
Yes, you're audible.
Yes, you are audible. Hi guys, good afternoon everyone. And myself, I'm Shweta Shetty from Cedlearn. So today we have a workshop on AI ML data modeling for prediction. So we are waiting for a few more people. So, like, l- let me introduce to you. You can introduce for everyone. Hi, Aditya. Good afternoon. Aditya, I'm audible. And yes, hi. So, everyone, guys, like everyone are from like a BTech background or some or any other backgrounds like people have. So, guys, please respond that anyone, if anyone has like everyone has like a BTech background or anyone has like other backgrounds. So mine is
Ma'am,
like
I am BSc Computers, ma'am.
hi Pavan, BSc Computers.
Yes, ma'am.
Okay, done. So BSc MSCS or MPCS?
MPCS, ma'am.
Okay, done. So
Okay.
I like even
Thank you, ma'am.
thank you. Aditya, so you told me BSc starts, right? Okay, happy even I'm from MSCS starts. Okay. And Samir, you're from BA. Okay, guys. So data analytics or data science, that guys like only it's not only for the BTech background people. So everyone can do it maximum. Like nowadays, the BCom people and BBA, BCA people are also MBA people are also doing the course and they're getting the jobs. So even the BTech people also can do. It is not in the BTech, even mechanical people and civil people also they are joining. So the course that data analytics and data science the courses are like AI also for not only for BTech people, any domain people can do it because it future is everything goes on AI. So and one more thing, guys, I just want to mention you people that so please join with your full name. Okay, just give me a minute. Yeah, guys. So everyone, please mention your full name because we are going to use it on your certification. Okay, guys. Oh, Triveni. Even we have one Triveni student. I think you're the Triveni. That Triveni, I don't know. So yes, even I heard that nowadays the BTech recently 2024 passed out students from recently 2024 batch. So they are like mentioning that in the BTech in the CSC they have AI ML domain, if not only DS domain, and in the like coming 2025 batch, even they mentioned me that DS and AI also, and some cyber security, what CSC cyber security. So I heard these all the domains from like recently people. Okay, some of the people are joining. So hi, Ayan, and hi, Chandana. Okay, guys, just give me a second. Okay, guys, the workshop is going to take by Mr. Suresh Kadari, and he's a CEO of our company. So as well as AI practitioner. So we are waiting for him. Let him come and we'll start the session. And guys, one more important point is that please stay like until the workshop end, because whoever leaving in the midway, they will not get the certification. Hi Tarun, good afternoon. Um, so, hi sir, good afternoon sir. Sorry guys, so sir is just joining in a few minutes. So we are waiting for him. And, hi Vikram, I think you didn't join properly. So yeah, please rejoin again. Vikram, I'm audible. So guys, if anyone have any doubts regarding data science or data analytics or AI, you can ask me. So I'm here to clear your doubts. I think no one has a doubt. Someone. Hi sir, good afternoon sir.
Hey, good afternoon.
Sir, today we have so today we have a session on AI ML and AI ML data modeling for prediction. So so we are conducting the workshop. So some of the guys they joined for a workshop.
Yeah.
So I request you to brief
Okay.
the workshop and everything.
Yeah. Okay. We'll give a few seconds. People are settling here, offline guys. So we'll give a few seconds and then we'll start. Okay.
Yeah, sir.
Okay. Thank you. All right. Are we good to go, Shweta, or should I
Yes,
wait?
sir, we are good to go. So some
Okay.
of the people they are joining still,
Okay.
but let me start, sir. They'll join.
That's the point. If I start, they will miss out.
Ha, sir, but
No worries.
people they are waiting from 5 minutes.
Yeah.
So
Yeah. All right. Okay. You need to stop sharing. You need to stop sharing. Okay.
uh,
Whoever. Huh?
I'm not sharing, sir.
Yeah. Yeah. All right. I got the con and I'm controlling. Select this. No, that's my screen. Good. Okay. Online, could anybody confirm that you can see my screen, please? You can hear me well and see me well? Online, guys, anybody? No.
Yes,
You
sir.
can,
We are responding in chat.
okay, but they can see me, they can't. Okay, now I think you can see my screen. I'm sharing a green and brown kind of screen. Can you see my screen well?
Yes, it is visible, sir.
Thank you. Thank you, Sanjay. Okay. Hey, thanks for being here for this workshop. Okay. We are going to today talk about what is AI, what is ML, and how we are going to solve a real life problem. Okay. We took a sample data set and I thought I will take through all these things. Okay. So most of the so-called ML practitioners, you are all want to be or aspiring to be a data scientist or data analyst, whatever. But machine learning is becoming a key, and most of the students or learners are just copy pasting the code and they are trying to tune it, but they're not understand the nitty-gritties of what is machine learning and how we do it. And most importantly, they're also not understanding the importance of EDA, feature engineering, those things, along with that. So today I thought I will talk about machine learning. And even if you have any questions on all, I can extend that knowledge, or we can proceed with EDA, feature engineering, and eventually I will show you the a workout how I solved a business problem and or hyperparameter tuning. All those things we'll cover. Okay, the main focus will be on machine learning, but machine learning cannot work on standalone kind of thing. So other applications, other processes help it. That's what we are going to do. Okay. So when I talk about machine learning, anybody, what is machine learning? Open question. What is machine learning? Anybody? What is ML? Yeah. What is ML? Anybody? Any idea? Okay. See, machine learning, when we discuss about, it's all about training the machines or algorithms. In this way, we are talking about algorithms so that you can predict or forecast. That means we are all interested in peeking into the future. So that is where we will give data, okay, and the models are algos. I will show you some of them. They will learn from the data. What they will learn? The patterns, hidden patterns and anomalies, everything. They will learn good and bad. So all those things learn, and it will be a hypothesis equation, which will help to predict our future for a future event. That means once you train the machine algorithm and you give a future value, it will predict or forecast for that value. Okay, so that is what machine learning is doing. See, this learning concept is human centric, and the first time software or calls or machines are learning. Here, when we talk about machine, it is not the computer. Okay, it is actually an algorithm, be it a linear regression or it's a SVM or whatever it is, a algorithm is doing. So what is the algorithm? It is a mathematical model. So that means this mathematical model is learning from the data so that it can create a hypothesis equation which will help you to predict something. Okay, so this is all. Gone are the days where we are talking about logical based systems. Now we are moving towards learning based systems. So logical based systems ruled world and brought us up to here, and from now onwards we are going towards learning based systems. Okay, so let's go into the architecture and see. As I mentioned, we have an algorithm, selection of the algorithm, or what type of algorithm you need to do or how you want to do. All those things are important, but if you look at it, has these four important parts. Okay, there is no machine learning without data. That is most important thing. When we are getting the data, it should be good in quality and quantity, volume, variety, all those things need to be there. That's why we say that garbage in, garbage out. So when the data is there, we have, our story starts. So from the data, we split into two parts. One is training data and testing data. Okay, so this is the split and all. I'll show you and we'll talk about that. So we need a training data that is part of the data set, the existing whole data set, and that we give to a learning algorithm. So this learning algorithm will read the data, learn from the data, and it is a mathematical force that trains the model. Once it is done, the outcome of any machine learning is nothing but a mathematical function. If you look at here, we have y equal to mx plus c. It's a simple linear regression algorithm. So this is very easy for you to understand. That is why I have represented here. So this is how you will get a hypothetical function that will be the result of the model. So when we say model, it is all included. It's a mathematical computation formed due to the result of an algorithm, so that when you give a fresh input, it will predict output y hat. So for a given x, what is the y? If you take this example, I can write it like simply beta naught plus beta 1x. Now, when I give data to this model, in this case, I'm referring to simple linear regression. when I'm giving the data, it will understand the patterns. Here we have only X and Y, only two variables. One is the target variable, other one is the independent variable. So dependent variable and independent variable. So this target variable is what we are interested in for the given dependent. So this variable and that variable, the relationship is defined like that. In case I say, for my convenience, that's the equation thrown out by this model, then any future value of X, say 3, will result Y hat as 9 plus 4, 13. So that is how you are predicting. So prediction is one important thing what we love in machine learning. So be it any algorithm doesn't matter. The concept, you need to understand what is machine learning and all. It is all about predicting. Okay, we have classification, we have clustering, we have other things, but it is all about looking into future or predicting what is unknown. Okay, that is what very important part we have. Okay, so look at here, you will understand this example of a computer vision, or it is not mathematical modeling again here. The complete data set I split into training and testing. One part, that is training, the majority part of the data set, be 70%, 80%. Again, we'll talk about that in the workshop. I mean, when I show the practical. So that will be the training data. And when you give that to the algorithm, it will learn and build a model. So Tom Michel said that E times T is P. Okay, E times T is P. So if E is the experience, that is, okay, at a task, which is identifying the dog, the more the experience you have, the better performance at this task. So that's what E times PT. So that means more quality data, more processed data, nice data, then my task of identifying a dog will be better. So that my performance will increase when my experience increases. Okay, that's why we say that give more data, more dog images. Okay, variety of dog images, side pose, front pose. So that is how computer vision, when we are using, we will do that. So once the model is done, you will get a predefined accuracy. Okay, that means you need to tune, you need to improve that. But already for a given data set, for given conditions, you will have a accuracy. Okay, this is the accuracy. That means there is 1.5%. Always there is error. That is what you are, trading off. Okay, if I want to improve this model to 99%, so that means I need to do two things. One is I need to work on the data side. I need to work on the algorithm side, that is tuning and all. So in the real life conditions, so once I build this model, I train the model, I package it. Okay, I got a acceptable or desired accuracy. Then I give a fresh input. This fresh input will be predicted as whether a dog or not. So that is how model works. This is the field data. So whenever you're training a machine learning algorithm, your target is to generalize the model. What is generalizing the model? Because you have a limited data set with a limited variety and variability and variance. So when you have limited data set and all, you're using it again and again to train hyperparameter tuning and all. But in the real life conditions, the norms may be different. The data may be very different than what you have encountered, because you can't predict what will happen in the real life condition, correct? So that is where, when the accuracy of the model is sustaining even in the real life conditions, we say that model is generalized. So generalizing the model is very important. Many of you must have encountered this, or many, even the working professionals encountered this in the lab or the computer or the server. The model works fine. Okay, the model works fine. But when it is done, it is given to the customer location, where the accuracy will come down, or even sometimes the models are rejected. This is called generalization failure. Okay, failed at generalization. So that is what we need to do. Okay, so now you got a picture of what we are going to do, why we are going to do all those things. Okay, so in ML, there is no certainty, accuracy of the prediction. And it only depends upon the data versatility and the model algorithm, what you're selecting. Okay, you can't predict that. Okay, you can't predict that. Good. So now I want to brief you. Many of you are aspiring data analysts, data scientists and all. There are two types of programming we can call. Right now in the real world, even now, we have these two things. One is the logic-based systems, other one is the learning-based system. Suppose you have application, okay, you have application, then you are going with the conventional technology. When I say conventional technology, which is popular and we need them, and without any disgrace, it is all about, suppose a full stack application and all you're developing. So when you're developing this, what you're doing, you're coding it manually. So everything is logic-based. So you will be creating a logic, how to identify a dog, cat, or even for the matter, rain prediction, whatever it is. Everything is logic-based. This is human involvement, and there will be a logic, predefined logic that goes into the code. So what to do? Suppose if I give you 1, 3, 5, what will be the next number? 7. Very good. So you are equally smart. But now, what will be the number at 100th position? Nobody can guess, because your human logic, whatever logic you used here, was last number plus 1. That means x minus 1 plus 2. That means the last number plus 2 is the number. Your logic failed when I asked with the 100th position. Why? Because you don't know the earlier number. So your logic has a limitation. That means unless you have the before number, you can't predict the next number. That is where the logic system works. That means literally, practically, in your manual coding, you're coding like this. This is how a logic-based system works. That is our full stack developers and all, they build the code and they will solve the problem. But how a machine learning or a learning-based system works? In a learning-based system, the same problem statement when you give, it will do the same thing what you have done. It will find out. Beyond that, it will also find out what is the position of each of these items. So then it will give me an output in a mathematical equation. That's what I was telling earlier, hypothetically. So it will throw output as 2n plus 1. So what does it mean? That means you don't look at the number, but look at the position of the number. So here, if you look at 0, 1, 2, 3, what you're looking for? 3. So 2 times 3 plus 1, it will result into 7. So that is what exactly predicted. Then now you're asking for the 100th position. You can guess it will be 201. So this is how a learning-based system works, and this is how a logic system works. So here, literally, I'm not doing anything other than cleaning the data, keeping the data correctly, and giving to the algorithm. That algorithm will do everything and build a h of x. That's the beauty of machine learning. Okay, that is why we are going crazy about machine learning these days. So there is no logic requirement. There is no limitation of human brain, because our logic has limitation and our reach has limitation. But machines have no limitation. So they will find out the underlying patterns and they will throw a mathematical equation. This is why some experts must have told you that when you go to machine learning, you need to learn mathematics, which you hate. But it's not about math, it is about understanding math. We are not going to create these equations, but we should understand the equation. So there is a concept, a bit out of topic. There's a concept now these days, explainable AI. There's a big research is going on, explainable AI. Why we are scared about AI? Because we don't know how AI is solving. Many of the problems what AI is solving right now, even the real life, we don't know how it is solving. That means what we want as humans is, whenever there is a problem solved, we want to interpret that. If I can't interpret, it becomes a black box. That is why most of the AI systems are running as black boxes. You're giving input, you're getting output, you're happy, absolutely fine. But what is happening in the black box, you don't know. In future, if the machine even does something wrong, you can't even cross-check or validate it. So you're blindly following something which is unknown. You created it doesn't mean that it may be good, it may be bad. So you created doesn't mean that you will blindly follow. That is where we're all a bit scared that the AI, ChatGPT is talking to you and everything is nice, but what is happening behind? How it is doing? many of the models, I say subtly that many of the models, many of the experts can't even understand how they are functioning, how they're doing. That is what making us scared about AI. If not, AI, machine learning is a beautiful concept. Beautiful concept. At the low level, when I can explain this to you, that equation, it is safe AI. But the AI is going faster and multiplying it itself and creating itself kind of real-time scenarios we talk about, people are getting scared because of the black box. Okay, that is why I say if you have some mathematical intuition, it is good for you to be a good professional. So it is all about understanding to an extent how model is working or performing. Hope you understood about how is the traditional program or conventional system works or logic-based system and learning-based systems work. So this is the entire process. I borrowed from somewhere. It is, you see, data acquisition, preparation, EDA. I will take you through all these steps today. So I thought I will show you what I'm going to do. So as a budding data scientist and all, you need to do data acquisition. Maybe you'll go to the database or you'll go to API or wherever, you will get the data and then you prepare the data. We prepare the data, we understand the data, we do EDA, cleaning, integration, reduction, transformation. That is all under preparation. Then you will, data set, you will go to the model. Again, your training and testing, 80%, 20%, 70, 30 ratio. It is all train test data. Then once the model is trained, it will give you a hypothetical equation and you deploy. Your job doesn't end there. Okay, so then what you will do, you will look at the field data, the prediction will be there, and there is a feedback mechanism which will be given to the training. And again, you will do model evaluation and hyperparameter tuning and all. So as a machine learning engineer, your job doesn't end once you create, a model. Your job will continue. You will improve the model constantly because I said in the field, the conditions are different and the conditions are different, model learns better. Okay, so you need to tune it. You need to tune it to the nearest condition. It is a simple example, a silly example. When you bring a bike home, what the mechanic will or the shop fellow will say that ride it, but after 100,000 kilometers, whatever, come back and we will do a free service. What is this first free service? After 1,000 or kilometers, they've asked you to come back. Why did they ask you? In the lab, in the manufacturing unit, when they tuned the engine, it was giving nice, 20 kilometers per liter or 30 kilometers per liter, nice, because that is on the treadmill kind of thing. They tested it there, they tuned it, everything is fine. But when you release that into the conditions, the tire will wear out and the engine will, wear out a bit of, and the oil consistency and temperature, everything changes. So this is the real life condition of the bike, not the one in the manufacturing. Then that's why after 1,000 kilometers and all, they hyperparameter tuning or the tune the engine. That's the same word they use, tuning the engine. Once they tune the engine, again, your mileage improves. So that is okay. Nowadays, we are getting pre-tuned engines, but I'm saying generally that is what we do. We deploy the model, customer will be using, and we'll be constantly engaging. We'll assure that initially at the lab condition, we got 95% accuracy. In the test condition, when you bring it, when you use it, it will come down. It may come down. I'm not saying that it will, it may come down. Then we intervene and then we do. That's why constant engagement with the customer and the data and the model is assured. Okay, so that is how this entire process. When we solve problems in the business side and all, we do that. We mention to the client that, sir, we achieved this much accuracy and this is what we do. Okay, some customers understand, some customers don't, but it is our moral responsibility, ethical responsibility to explain them and all. And of course, they don't check every day what is the accuracy kind of thing, but we can tell that initially the model will settle down. We say, technical word, we say model will settle down. And what is the settle down? The ripples will slow down because the fresh input data, field data will be very unique. Field data will be very unique. That is how we tune it and then we achieve and then it will go on. Okay, it will do the process on its own. In some AI systems, it will self-test it. Okay, that's why machine learning, still we are involved. Okay, that is why, see, AI is umbrella term. We cannot say that AI is something which you can tangible kind of. It is an umbrella term. Under that, we have machine learning, we get deep learning. Some models under AI or neural networks, they can self-tune. Okay, but that is beyond. So here we will talk about simple machine learning where we are deploying and we involve in the process of tuning. Hope you understood that. Okay, so we have these 5 steps. I will take you through these 5 steps: data acquisition, data pre-processing, model building, model evaluation, and optimization. Okay, so data acquisition is anybody's game. Data will be given to you, or you will go to the source, that is a database or anything, you will take the data. Okay, so when you get the data, your job starts. These days, most of the customers are not giving you, Excel file CSV. Those days are gone. Thanks to volume and variety and the security reasons, they are giving you access to the database. When they give you access to database or anything, so you will get the data from there. Okay, then you pre-process it. That is what today I'm going to show you. And model algorithm selection is also one of the important things. Which algorithm? Most of the machine learning enthusiasts, what they do is trial and test method. They run machine learning, or they use all the algorithms on the data model and see that, okay, this model is working, or this model is, or algorithm is giving high accuracy. That may not be the real accuracy. Okay, so because you have limited data, so all those things you need to learn. Okay, then it comes to model evaluation, visualizing, testing, validation, all those things you do. Then you optimize it after tuning the weights and all. Good. So we'll go with that knowledge. EDA and feature engineering, I will cover as part of our workshop data. Now here, I have this data. It is house finance company detail. Okay, it's for a home loan. US data. Some of them are fine. You see, I have anytime whenever you get the data, first thing you need to see is whether you have the variable explanation or not. Most of the clients will give you. If not, you can ask the client. One thing you need to remember: until your EDA, until your feature engineering, you can always interact with the client. When we get the projects and all, it is not that client will dump and vanish. Okay, I'll come back when the solution comes. No, always interacting with the client is good, especially for a data analyst. It is very important. Okay, for data scientist, the process is same until EDA and all, because the model, the data sufficiency or insufficiency, you may encounter at any point of time. Or sometimes you will be working on such a domain which you don't have any idea. Suppose you are suddenly called onto a medical project or some other project. These kind of things we pick in these workshops and all. Why? Because you can understand when I'm saying something. I, even in my life, when I encounter some problem statements, I never worked in that domain. So will I step back? No. As a machine learning engineer, you can solve. We know data, how data behaves, how models work. That's enough. What we don't know is the domain knowledge. That is where we'll go to the client, ask them for 1 or 2 meetings to explain the code, explain the variables, features, and then learn from that. Okay, so customer will be part of our exploration. Good. So here, if you see, we have gender, marital status, education, and all. These are all very important point for a bank to clear your loan application or not. So we have one loan status that is approved, yes or no. Other than that, everything else is our independent variables. This is the dependent variable. Here is the clue. When I can identify, or when I am identifying a dependent variable and independent variables, of course, without independent variable, there is no model. You can't build a model. So, but if I can identify dependent variable, that means I'm going towards supervised learning. So this is the clue for you. If we know what we are looking for, it is called supervised learning. That means I am, in other terms, I am supervising the learning. I'm telling what is X and what is Y. Okay, these all terms can be X and this is Y. This is how supervised learning. If you can find out the target variable, here is a label data. So I show that this is the Y you are targeting and this is the X you are giving. So what is the independent variable? It's an explanatory variable. It is the causation. And what is dependent variable? It is the effect. Okay, so this is what these all gender, marital status, education, and all is causing the loan status. Whether should I give you loan or not, these things are matter. These matter for us. So that means these are the, the variables which are affecting our cause, that is low norm. You understood? Now, with this look, I can say that this is supervised learning, and okay, most of you are young, budding machine learning engineers. So, okay, here I have a habit of keeping all my libraries and all importing over here. So looking at this, you may understand my approach. I'm using pandas, NumPy, Seaborn, which is a good visualization tool, okay? And most of you explored. Matplotlib, must tool. We all started with Matplot because plotting, simple plotting, okay, you learn from there. It is very good tool. But after that, we go to Seaborn. And after that, we have so many PyPlots and all are there. So libraries don't mind libraries. As we are speaking, maybe somebody is launching a new library for Python, visualization or machine learning. Okay, so don't worry about libraries. If you understand the underlying, what is the content of that, or you understand the knowledge, you can apply that and learn any library in a short time. So most of the times we use two-dimensional data visualization, but three-dimensional, okay, scatter plot kind of things are also available. So here I take all those things, modules, and then I go here. So first thing is I need to grab the data. So I go and use pandas. Most of you must have done this earlier. Okay, DF, don't use short DF and all. It always need to be DF underscore loan kind of thing. But again, okay, I want to keep it simple, short, so that when you look at it, it won't scare you away. So data frame I'm creating, I'm reading using pandas. So we use right-hand side method. Whenever you want to analyze anyone's code, go with right-hand side. So we are coming here. Hey, go to this location. Yes, I went to the location. What should I do? You will find a CSV file. Yes, that is a CSV file. Using pandas, read that and convert into a data frame. When you're done, create an object with that. So I did that, and then DF head, top 5, and I go to describe. Many of you have half knowledge, but describing the data is very, very important and the first step. What is describing? It is simple terms. It is the descriptive statistics about the data. So descriptive statistics about what we have here. So we have so many variables. How many? Actually, you can look at, I did somewhere, okay. Yeah, 613 entries, but columns wise 12, I believe. We will find out when I do 12. So out of 12 columns, I am describing the entire thing. If you look at here, only out of 12, only 5 are appearing. What happened to the other variables? What happened to that? Why? Anybody? Yeah, very good. So descriptive statistics, or the describe, will only consider the numerical variables. The object or the non-numerical, okay, categorical data, it won't consider. It is not that we can't apply statistical method on categorical data, but we can't apply all the statistical methods on categorical data, okay? Only method we can do is frequency or mode we can select, okay? So now if I talk about education, it is not appearing here. Why? Because it can do mean, maximum, 25%, 50%, all those things. It can calculate only for the numerical data. Quantitative data, it will describe. Saying that you can also include object type and get descriptive statistics about the object type, but that I'm not doing. So then I gone to the info because client has given me. Now I need to identify how to do it. So I have here data columns. I have 13 entities, okay, and 614 entries I have records. So all these I have 0 to 12. Loan ID does not, it won't matter to me. I can find out from here with the info. I will first check, okay, there are non-null values, and then 614 non-null out of 614. So that is fine. Wow, there are some null values. Okay, there are some. So this is fine. Okay, this is fine. This is fine, kind of thing. Okay, then I check the data type. Okay, these are all object. Application income. Sometimes I see loan amount should be a float or integer. If it is showing like a object, then I will make a mark out of it. Why this amount column is showing as object. So what is the object? Data type object online? Anybody? Just to engage you guys. What is the object data type? Do you have any idea what is object data type? Anybody? You try it out. No worries. Online? Okay. No worries. Okay. Whenever we have a string data or a mixed value, we call it as an object. String or mixed. So I have, suppose if you have, suppose 1, 2, 3, this is integer. But if I have 1, 2, 3, m, it becomes a mixed value. Or a string, any string becomes it. So object, see, I can understand. So I will see self-employed being object is fine. Loan amount float, I will see. This is how we mark. This is how I'm showing how I solve the problem. So we write notes every time. Observe, okay, what is happening? Okay, there are so many null values. Here, suppose, here, there are so many null values. Is it important? If it is important, I need to work on that. If not, I will speak to the client and say, hey, client, it is not so many missing values or null values. What should I do? Should I take it out, or you have any other data kind of interaction I have? So before I take a unilateral decision, always I take a client into confidence. Now I'm pre-processing the data. Here, what is pre-processing the data? I need to find out whether null values are there. Already, I know that there are null values. I know that null values, but I don't know where and how much. So that is where I'm asking, is null? Hey, data frame, do you have any null values? If you have, how many total them? So for loan, there are no null values. Yes, and all. So whatever I have, okay, I need to work upon. If this is 50 null values, something really, really wrong. I need to find out. So with using my domain knowledge here, that's why every data scientist must have a domain knowledge. Every data scientist must have domain knowledge. Most of the students, I keep on telling that read or explore. Okay, but most of you only care about technology, code. But here, if you see that credit history, okay, how I use my domain knowledge to analyze this data. If somebody is applying loan and there is no credit history, you clear the loan, but you don't have credit history. That means if you don't have credit history and still clearing the loan, it is an unsecured loan. It's an unsecured loan. Now we can think that how can somebody give a loan without having credit history? Maybe the first time users, even the first time users, but how can this miss out? So this is a must. This is a must. See, a minimum domain knowledge about banking system or the finance system makes me a good data analyst or a good data scientist. If you are not having any domain knowledge, you will just run this. Like 90% of the machine learning engineers, you will just run this. But a good data scientist or a good machine learning engineer will ask good questions or right questions. When I ask right questions, the customer will give me a right direction, and with that, my model accuracy will improve. So if I have this blank, and some guys in future, it is becoming a mandatory that everybody should have their credit history, the accuracy may not be good. See, this is how sometimes domain knowledge helps you to achieve. So self-employed, 32 blanks, it doesn't matter whether you're self-employed or a employee, doesn't matter for my calculation. But this one matters. So this will be a question for my client. This will be, I will just let it go. Or as a side question, I'll ask, do you want me to do this? What do you want me to do? Yeah, no, not applicable. Okay, or keep it as self-employed. Whether you're self-employed or this employee, that also matters. But most important thing is credit history. Without having credit history, you can't issue a loan. Okay, good. So that is the risk factor. Some banks, some other type of financial institutions, they go with these unsecured loans. We are not talking about that. Here is the bank data, so we can ask for question. Loan amount or loan amount is missing. If loan amount is missing, I can't proceed. So all these things matter. Okay, then I interact with that. See, one analysis and how much. So here, whenever you have missing values, I always say that you have 3 methods to fill. You have 3 methods to fill or 3 ways to address missing values. What are those things? first you can delete them. Okay, that is unilateral or in concurrence with the client. You just remove the problem. Data is missing, remove the record. Problem solved, but not always. Okay, it depends upon what kind of data. If one missing value and you're deleting the entire record, it makes no sense. But if this missing value is very important, without that you can't proceed, it is okay to drop. It is okay to drop. So, but if the data number of records are very minimum or limited, then you can't do that. If you have 100 records and 5 missing values, then you can't sacrifice 5% of the data. Okay, 5% of the data you can't sacrifice because they have missing values. That is where you need to talk to client and understand what to do. But at the same time, if I'm having 10,000 rows and only 5 are missing, I can sacrifice, maybe I can sacrifice the records. You understand the logic here? Online? Is it clear? Very important point. So this is how you will make a decision on dropping or not dropping. But always, as a senior guy, my response asking, don't take unilateral decisions. Whatever you're taking, for your analysis is important, do it, but record it or take client into concurrence. Okay, good. Because we are understanding data. We understand data well, but the domain belongs to the client. Okay, unless you have absolute clarity on the domain, don't make unilateral decisions. Okay, good. So then the second method is imputing. Imputing. What? Replacing or imputing. The data is missing, keep some data there. Okay, put some data there. So how you will do it? Again, you will have two methods, sub-methods with that. One is you make a call, that is your judgment call. Your judgment call that, okay, if one data is missing, take the forward fill or back fill. That means if one of the person's age is missing, take the next person age and fill it, because they are sitting together, must be of same age group. That kind of judgment. Okay. Or I know that the average age of some students is 18. So keep 18. So I am making the call. Either I'm replacing the value or I'm giving a value. That is both the case. We are replacing or imputing. The next one is statistical method. This statistical method is the safe method, but always not possible. Statistical method is fair. Here you will use mean, median, mode kind of statistical analysis and then refill it. Suppose in the student's data, in the student's age data, couple of values are missing, then you won't make a unilateral judgment and say keep 20, but you will calculate the average or mean of that variable and that impute. You will give that value so that you are backed up by some mathematics. That is called, statistical method. And the third one, these days becoming very popular, is machine learning, ML models. That means you will run a model on this, looking at the missing values and decide using a machine learning or predict the missing value. You can predict the missing value and you can refill that. So machine learning algorithms are helping you to find out the missing value. So this is how we use 3 methods. Okay. Here, just for your argument's sake, I'm just showing. Okay. Here I lost my logic. I just want to show you how I do it. So fill NA, null values. I'm filling with mean. That means I'm going with a mathematical statistical model, mean. So here I am filling the married column with my own judgment. Okay, because you're applying for a home loan, of course you must be married, that kind of judgment. Okay, so I'm saying that if the married column is having any null values or missing values, just fill it with yes. See, here my judgment is coming. Maybe if you may say fill it with no, but here you and I are all depending on the same statistical method. Okay, there is no you and I here. It is math. And here, fill NA mode I'm using for gender, because gender is a categorical data. Gender is a categorical data, which is talking about male, female, and I'm going by the frequency. Mode is all about the most popular value. So I'm saying that most popular value, whatever it is, you please use that to fill that. Okay, good. So this is where we did that. Now, after doing my filling or whatever, handling the null values, now again I'm checking what is before, this is before, and what is after. Glad. Okay, brilliant. We removed all the null values. Out of all the mischievous things in the data, null values are dangerous. Null values are always dangerous. So do not, okay, entertain null values. With null values, your data accuracy will be very less and you can't depend on that. Okay. So now when I did that, everything is good. One more thing, did you observe? Okay, data type is integer 64. That is one important. Now I'm going with my analysis, explorative data analysis. Here I start with univariate. Uni means single. One variable analysis, univariate analysis. So I'm using a single variable analysis. And here, okay, here I have categories. Okay, sorry. Okay, I'm doing subplots 4/2. Okay, 4/2, and figure size I given. So I'm adjusting that, and I'm giving a title, and all those things I did. Okay, and I'm giving you different plotting. Here, visualization is the best method to understand data. Visualize is the best method. So here I'm going by counts, because all these things, whatever I'm having, categories, gender, married, dependence, education, these are all categorical data. So hence I am going with count. That is the frequency. So look at here, male, female. There are more male, okay, compared to female. Is it true? How do you know that it is true? Maybe when the gender column has come, I have 13 missing values, and those 13 missing values, okay, gender, I filled with the maximum one. That means already male population is high. Into that, I contributed 13 more values. See, here, if I do something wrong, if my method of approach is wrong, I am contributing to the data worst side or the best side. See, would have been here. This would have been here. I added 13 more. But my judgment is when there are 500 such values, 13 is okay. My judgment I've gone by. So male, female, socially, even this is acceptable, because in the society, or in this Indian culture, more male will apply for the loan and female will be co-applicant, or less female working population, hence less loan applications. So if I'm a bank, what I can do, I know that female population is less, but not that less. Not that. That means more female could be targeted for home loans. See, not only your job, when customer looks at this data, he says that, wow, out of all the population, how many loan applications we are getting, or sanction, in this case, sanction, okay, I want to see that I am observing that there is less female ratio. So that means maybe I'll tell my marketing guys as head of the bank that why don't you increase your target for female population? Okay, see, not only one, when you give this to client, they will understand more. That EDA process, even for us, is the same thing. We want to understand, okay, there is more male, okay, here, count plot, married, more married people are appearing, applying than member. But if you see 50%, so that means this is also significant. So this is also a significant portion. Okay, and here we have dependents. So the young couple are more in the population than 3+. Why? Can anybody explain? Socially, this is a social question, not technical. Why 3+ are low socially? That means people are having 3 kids, can't afford home. Why socially 3+? I'm not saying technically, socially. Just you understand the market, right? You are a child, you are a parent or something like that. So why? Online? I want to see whether you're sleeping or with me. Guys, offline? So this is where I always say domain knowledge. We all rate ourselves as very high. We are smart guys and all. But see, there is a social problem, and the bank guys are asking, what should I do? Okay. So somebody said, according to current economy, thank you, Triveni. 3 plus not, oh, no, Aditya. We can't say that 3 plus not acceptable. Okay. We are not in China. String, yeah. Okay. See, simple thing. I go by this logic. My logic may be correct or wrong, but my experience. So a person is having 3 kids. Usually, when do you apply for home loan? When you are in first job, first kid, by then home loan will be done. Okay. When you get the job, your mom and pop will be after you. Take a home. And by the time first kid, second kid, 3 plus means already you are above 40, 45, kind of. So most of the time, these guys won't take a high risk such as home loan. Home loan is like 1 crore kind of commitment. By then, you are done with your requirement, or it is very rare that you will go. So as a marketing guy, if I'm running my ad campaign, I will run a campaign that, okay, 25, maybe the age you will get a job, or 28. 28 to 35 is the period I will target. So by then, maybe you will have 1 kid or married, or you may be having 2 kids by 35. Okay. So that is how one reason it could be. You understand? So anything can be analyzed. So this analysis, if I write my report, if somebody is a add-on question from the client saying that, tell me, when you're doing all these things, can you find out what should be my target group? If the client says, when you're doing all those things, find out what is my right target group. Then I say, sir, as per that, you target up to 40. Don't target beyond 40. Okay, beyond 40, don't target. Maybe somebody is a late bloomer, started slow, and by 40 have 2 kids, okay, and going for a home loan. But beyond that, it is very rare. I'm not saying that nobody will apply. Okay, who am I to decide? But the application will be less when you have 3 kids, you can't afford a home loan, or you already have a home, or it is too late for you to go for a home. Okay, so that cases, I won't say zero, but see, anything can be analyzed. Here, plot education. Yes, more graduates, less graduates, even not graduate. That means when we talk about not graduates, there may be link with the, what is that? We have this index, loan, we caught about, index, what was missing. So maybe you're a not graduate, you don't have credit history. You're a not graduate, and maybe you're a businessman. Maybe you're a businessman, so you don't have a credit history. It could be like that, right? So if I want to check, maybe I can check if you're a non-graduate, maybe you're a businessman. Maybe I link that. If a non-graduate and businessman, believe me, machine learning will also check this pattern. When somebody is applying for a business loan and non-graduate, maybe it is a businessman. So all these patterns, whatever I'm analyzing with my simple human brain, machine learning does that everything in a spark of a second. Okay. So look at, so there are more graduates. So that means I can release my ads in English, or I will target guys who are graduates. But at the same time, if I want to increase my market share, I will also target non-graduates. Okay, good. And self-employed, you see, most of them self-employed. Why? The banking system supports, this kind of thing. So self-employed are more here. That is something, sorry, yes and no. Self-employed, yes, is less. That means less businessman, more, what you call employees, because you will have fixed salary, you have salary certificate, documentation, everything. But if it is this guy, businessman, lot of, ifs and buts will be there. So this is how I analyze. I'm just showing how my mind works. Okay. And again, I told you, EDA is an approach, not a technique. My approach may be different and your approach will be different. But anytime you need to go through data like that. If you have any queries, write down and ask. Okay. These are my observations, which I made earlier. So now I want to go with the subplots. and I want to see how these KDE distribution, kernel density estimate, how these distributions are working. So if you look at here, for applicant income, but distributions we can draw only for numerical data. So I am taking the numerical data and loan amount and all I am doing. So when I do this, I understand the distribution. What is a distribution? Distribution is all about spread of the data. Okay, in the spread of the data, there are lows, there are highs, and there is a range. Okay, spread of the data. Okay, so this is how we get distributions. Okay, so I'm understanding that, okay, co-applicant income is more towards that side. So KDE, kernel density estimate graphs, I'm doing it. Okay, so I am getting my graphs, all the graphs done. Okay, I'm seeing that there are multiple peaks, and then, okay, credit history, yeah, it is going from here to there. So all those things done, and there is my understanding. So then I go with bivariate analysis. What is bivariate analysis? By 2, uni 1. So here, simple thing, I'm using scatter plot, and for x and y. So I have a x and I have y, and I'm doing the scatter plot. This is the independent variable, and this is the dependent variable. Okay, so scatter plot, this is where a small trick I'm playing. Scatter plot is a 2-dimensional one. I can convert the 2-dimensional graph into 3-dimensional graph by using what? Hue indexing I'm using the color to convert a 2-dimensional graph into a 3-dimensional. That means I have now applicant income, loan amount, and loan status. So yes is blue, orange is no. That means when your income was such and such, okay, and the loan amount was such and such, you were not given. But at the same time, you secured a loan. So all these things I can have 2-dimensional data with 3 dimensions indicated over it. Okay, so we go to the general observations. So loan approved, predominantly observed as in the low income or low amount range. That means most of the banks are playing a safe game, or this bank is playing more safe game. How do you understand? See, the concentration of the loans are towards the applicant income, low income, and low loan. Okay, very few high income. So if I am the client and I look at this bank and I say, no, I won't go for big loans over here, because this bank is, targeting the clients who are 20,000 kind of income group, and the loan amount is not more than 300. So it is a small loan kind of thing. Okay, it's like a loan against your paycheck kind of thing. So look at, so this is a beautiful observation. So now there is a huge scope for increment. There's a huge scope for increment because you are not targeting 80,000 and all. Maybe the demand from them is high or the risk is high, whatever it is. So your loan process is that. Good. So like that, I can do all my analysis. So this is where I get insights for decision making. Income level significantly impacts loan approval. Okay. But other factors, credit history, co-information may also play a critical role. This is how we also say the communication is important for data scientists. Why? Because you need to understand and then you need to represent well. Any failure, your model or your workout, your project submission will be not good. Okay. Here I'm going by group by, okay, and I'm finding out rural, semi-urban, and urban. How is my loan amount? Okay, urban, I don't know. Loan amount is low and rural high. So this is all my analysis. Then average amount, how much it is. So I'm doing a heat map and finding out female, how many, gender versus marital. So if you're married, see, maximum is, okay, male and married, and female married, female not married are also there. So this is how I do all the analysis. So this is, here I'm finding the outliers. What is an outlier? Outlier is any point that is beyond the boundaries. Any data point that does not belong to the group is called as an outlier. So any data point. So I'm trying to find out using the box plot or whisker plot, these things, that what are. So I can say that there are, graduates more loan. If it is a non-graduate, see, there is a clear-cut demarcation. So that means if you're a graduate, you can expect more loan. If you're not graduate, you can, you may not get secured. So even the non-graduates, they got loan, but under stream, this is the upper boundary. This is the upper boundary of graduate. That is where. What is the upper boundary formula? Q3 plus 1.5 times of IQR. What is IQR? That is the interquartile range. Okay, so these all things you need to learn. If you want to be good data scientist, you need to learn these things. Not merely looking at outliers are there. Okay, why you are calling outlier? Where is the median? This line is the median. And how you are comparing to all those things. Good. So I'm done with that. Okay, I did my analysis. Then I am going for multivariate. What is multivariate? More variables against more. So this is where I got a heat map. Okay, correlation map. See, I'm using correlation. Okay, correlation. And this is the correlation I found. So this is what is a correlation? It is quantifying the strength between two variables, how they are positive or negative. Okay, are they? And the range will be from +1 to -1. 0 means no linear, no relation at all. So this is what we learned. Okay, this is very important. See, stats is so much important for machine learning. Okay, without learning stats, you can't understand this. I'm briefing all these things because I love stats or I'm understanding stats. If not, you will say the correlation is high, correlation is low. What do you mean by high, low? So please focus on bit of stats, bit of, not most of stats. Okay, so heat map, when you look at, this is one chart, but the chart you can read only when. See, in this sense, I can see only this is the high correlation, positive correlation high. Do we have any negative correlation? We have negative correlation, but most of them are, yeah, this is the maximum I can find. Don't, mind this 1, 1, 1. That is you to yourself. Okay, so that is the heat map. Good. So beautiful one. So I know that applicant income and the loan amount. Yeah, of course. It's a known fact that as your income is more, your loan amount could be more. But here, loan amount versus co-applicant income. Yes, of course. Co-applicant, the process is that if you can't secure a loan, then your co-applicant will give a backup. So that means there is high correlation between loan amount and co-applicant also. See, beautiful analysis. This is how EDA is most important thing. Without understanding that, what is the point in going for machine learning? Okay, machine learning is only 4-line code. Believe me, literally, I'll show you 4-line code. So with that, what you will do? So this is why you work on EDA and feature engineering. Now I have enough knowledge, enough understanding about what is going with the data, how the interdependencies are there, what are important variables, what are not important variables, all those things I have. Now I'm going with feature engineering. Okay, somebody's talking. Not acceptable. It's like not able to manage. Yeah, Aditya, correct. In your way, you are correct. Okay, feature engineering. Okay, here feature engineering is a beautiful concept. Every machine learning engineer must focus on feature engineering. Most of the guys, when I interview for my IT company, when I interview, they talk about all things, but when I come to feature engineering, they don't know. They learn it like a theory subject. No, it is most important. Okay, because machine learning, okay, it is depending on the data, features. Okay, if there are more features, less features, interdependent features, correlated, non-correlated, independent, all those matter. My accuracy, my prediction will affect with that. So without feature engineering, you cannot be, you cannot achieve a good probability or precision in the prediction. So one of the things what we do in feature engineering is we have so many feature scaling, creation, transformation, and engineering and selection, so many a thing, but many or may not be applicable every time. Okay, so I go with here feature creation. What? I'm creating a total income. Okay, I'm creating a new total income where applicant income plus total co-applicant. Because when I'm saying total income, I'm considering these both. So I'm creating a total income and these two are coming along. So here I am doing feature creation from the 12 plus 1. So I have 13 now. Okay, then we have feature transformation. We have feature transformation. Here I do feature transformation because sometimes data will be skewed. See, again, I'm talking about stats. When the data is skewed, what is skewness? Measurement of symmetry. Data is expected, many of the algorithms expect data to be symmetrical. Nice, 50-50%, beautiful data. No, in the real time, this is how data looks. Okay, so when this is the data, then you perform transformations. That is, you're transforming the data using log, exponential, and all. So reduce the skewness, improve model performance, handling outliers, interpretability, visualization, all those things you achieve. So here I opted for log transformations. Log transformation will be like that. So log transformation I opted, and now this is, I'm applying, you look at here, I am creating the log transformed values, np.log, numpy.log, column, okay, adding 1 to avoid log 0. Okay, so I am doing this and I got my log transformed values. These are post log transformations or post transformations. I will take you up a bit. These are pre, you look at skewed data, look at the skewed data, post transformations coming into nice, okay, data. Not every column will respond equally, but I just shown that I applied to all and showing how they are responding. Okay, not every column. That's where you have so many log, exponential, all those things. You have different transformations. You understand those and apply. Do I need to learn all things? Yes. Do you want to be a good data scientist or machine learning engineer or a normal one? If you want to be a normal data scientist or a machine learning engineer, you don't need to learn all these things. But you want to be good one, get big packages, big companies, you better learn all these things. Okay, that is how in the interview I check this. Then I can say whether you are a serious guy or a normal push button kind of guy. Okay, so both have jobs. I'm not saying that every only serious guy. No, both have jobs, but depends upon whether you want to be a 20 lakh package guy or a 10 lakh package guy. Okay, obviously there will be very few that level package guys. Okay, so these days what you have is time. What you have is time. So invest the time in the back-end operations. Invest the time in back-end operations. Okay, you guys have some questions? Huh? Questions? Ask me. No, we are not going there. I'm explaining this. Well, after this, I will. Okay. See, feature engineering, as I mentioned, we have the word engineering. Okay, is a big word. Okay, so under this you have so many things. So some of what I did is feature creation, feature transformation. You have scaling. Okay, you have selection. All those things we use for the same feature engineering. Okay, so but what to use, what not to use depends upon, okay, on your data and the problem state. Okay, good. Let's go. Then feature selection. This is absolutely fine. Okay, absolutely fine. So in the feature selection, what we are doing is here I'm again using my domain knowledge. So without having domain knowledge, okay, you can't select the features. This is where I am using my domain knowledge and whatever analysis I've done until now, plus this. Do you have any question again? Okay, feature selection, I do that. So what I'm doing is my domain knowledge and whatever analysis I did. In the analysis, I may find that education qualification is high important than other parameter. Or I may find that whether you're married or not more important for a loan. Or I may find that how many kids you have is also important for your loan. So if I take that knowledge with my domain knowledge, I will finalize my selection. See, until now, I've been speaking for last 45 minutes. And where am I? EDA and feature engineering. Then where is machine learning? Machine learning, believe me, it's only 3-line, 4-line code. The moment you come there, I just pass by. You don't even realize. So the entire game is in EDA and feature engineering. Because garbage in, garbage out. Many of these challenges, whenever you participate in machine learning, you directly go onto the data and use certain algorithms and all, and you publish and say, oh, this algorithm is giving. But actually, what you need to do to improve the accuracy, if you look at the guy who won the challenge, they will go with the data properly. They will go to the data properly. They will do analysis properly. They will select the selection, okay? Transform the data, scale the data, all those they do, and that's how they achieve. It is not that he is or she is writing one more line of code in machine learning. In the logical based systems, the good coder means you will write more code and more logical code. Here, nothing. Even a good model will have 4-line code. Even the worst model will have 4-line code. Then where is the magic? It is all in the data selection, EDA, EDA, feature engineering, and hyperparameter tuning. How you're tuning the algorithm. That is why I say that it's a beautiful one. Okay. Pooja, hey Pooja, I have a marker. Only I can draw. Okay, don't worry. You're curious, how am I doing this art, beautiful art? I have a marker. Okay, this is the software I use. Demo Pro. Okay, Pooja? This is the third time you attempted. Don't worry. When you will become a machine learning engineer, like this, I know you're all 30, 40 guys listening to me. Okay, you will get that chance. Pooja, good luck. Okay, back to the class. And you understand now, this is the feature selection. Okay, so believe me, you need to work on these things or these concepts very good. Because when I show machine learning, for you, I took 3 or 4 algorithms. All the algorithms I want to show how much is the code. All the algorithms, only 3-line, 4-line. Okay, so don't focus on machine learning. Don't take it wrong. Focus on machine learning. What I mean is, don't overemphasize on machine learning. Emphasize on parameters, how to do the hyperparameter tuning and feature net selection of the data, which parameters. If I give here, I am considering 1, 2, 3, 4, 5, 6. If I give 7 or if I give 5, there will be change in the model performance. Okay, the model generalization may fail or generalization will be better. It all depends on. Okay, so this selection of the columns or features is very important. Look at, I got my columns ready, then I am good to go. Okay, so I am finding the correlation. After doing all these things, my correlation did not improve much, but it's okay. Whatever we got, we got. Okay, so here you see some correlation improvement. Earlier it was 0.19. Now it is 0.49. It decreased. Earlier it was 0.59, I believe. Now it is 0.5. Doesn't matter. See, there is improvement. Applicant income and co-applicant income. See, there is correlation. So these transformations help. That means now my machine learning will get good accuracy. Okay, earlier I was searching for where, and now I'm finding few numbers here and there. Okay, guys, good. Until now, any questions? I'm done with my feature engineering. Any questions for me? Guys, any questions for me? Am I doing good? We have some cheeky guys here. They're making jokes of me. But other than that, rest of the guys are very serious. Okay, any questions? No? Anyway, here also no questions. Okay, so we go with feature encoding. What is feature encoding? Encoding. I'm coding, encoding. So that means, suppose you have a categorical data like gender. Machine won't understand what is male, what is female. Machine is built to understand only numerical data. Okay, machine is good to understand numerical data, but our brains actually work on categorical. Married, unmarried, good. 1001, you can't understand. I can't, if I give you code, okay, elderly 5, okay, young person 2, you won't remember. So, but this, okay, so here machines want or machines need numerical data. That means this male should be converted into 0 or 1, whatever. It's not, I am saying that you can go 52, 53. What does it matter? Okay, but whatever it is, you need to have encoding. So that's where I go with encoding. This is encoding. So what is this encoding? Here, I can use label encoder. We have label encoder or one hot encoding. One hot encoding. Okay, which is the better? PHP or Python, which is code, this code, Puja. Puja, this is Python. Okay, this is pandas. Okay, this is pandas. And yeah, PHP. Okay, I know that's a big topic, but I will start. To achieve machine learning, programming language doesn't matter. Honestly, programming language doesn't matter. But Python rules the world. So most of the 90%, or if you allow me, 95% of the population use Python. Okay. You can achieve machine learning using other programming languages, but this became a popular programming language. So thanks to community support and libraries and all those things, we go with Python. Okay, Pooja? Yeah, as I mentioned, okay, here we are not using Java. We go with Python. Thanks to community and the support and all, Python made life very easy. Okay, dear? Python made life very easy. Good. Okay, thanks. All right. So here your indentation. Indentation we are using. Good. Okay. So where I was? Okay. This I am importing pre-processing and label encoder. So that means all the gender, male, female will become 1 and 0. Married, dependents, education, everything will become encoded. So we have label encoding, we have one hot encoding. Okay, if one hot encoding, what happens? You must have learned gender, male, female. Okay, one hot encoding, 0, oh sorry, 1, 0, 0, 1. And label encoding, 1, 0. So this is how, if you learn properly, okay, you'll understand that label encoder and one hot encoder works like that. So here I'm going with label encoding and I'm now getting, okay, 614 non-null values. Beautiful. And everything is numerical. Earlier we had, okay, so I am good to go. Now I'm entering the world of machine learning. Believe me, now you count. Now you count the line number of lines code we have. Okay. This I treat as pre-processing. Still I treat as pre-processing. I'm not going into, but this very important part. This is the model selection, under model selection, but still I count neither here, neither there. Okay. So here from the scikit-learn library, and before that, I'm dropping the loan status. Oh, I need to tell you this. So we have X vectored and we have Y. Okay. So what is X? X is the independent variable. What is Y? Target or dependent variable. So X and Y I have. And here for X, we have X1, X2, X3, X4, and so on. Earlier, when I was explaining simple linear regression, I was having only one independent variable and one dependent variable. But here I have more than one. Okay, more than one. So that is where, okay, I'm coming here and saying that all the X values and Y. So all the X value columns and one Y. If I drop this, if I drop the last column, that is loan status, if I drop this, it will become X. If I remove all these or discard all these, that becomes Y. So loan status only alone I give to Y, except excluding loan status, I give to X. So this is how I'm dividing X and Y. So now I have successfully divided X and Y. Good? Okay. So now when I divided successfully X and Y, next step is train and test. That means in the same X and Y, some data should be called as training data, some data should be testing data. That's where it will be X training data, Y training data. That means 70% of the data I'm keeping for my training, 30% of the data I'm keeping for my testing. Okay, if this is the training side, this is the testing side. On the training side, I have X, I have Y. So X training, Y training. X testing, Y testing. So this is what, see, X train, X test. Y train, Y test. And what is the ratio? Okay, 70-30. And random state is 42. Okay, so I give these two values, objects, and then ask them to test. Now model training. Okay, so when the model training, I am using, look at, I'm taking cross validation, train test split. Okay, I can't explain, but now I'm creating a function definition dot classify, and I'm using my cross validation and the cross validation of the mean score I'm calculating. Okay, so when I'm giving all these things, my model accuracy, I will say, see, cross validation. So it is K cross validation, default folds, I'm using 5. So what happens? I will simply tell you. So whenever you are having a data, we are training and testing, we are dividing. So the there is a problem in this. So there's a problem with this method of training and testing. See, actually, the models are failing at generalization. Why? You are training and testing, but there is no validation. So that means actually you need to have 3 parts: data for training, testing, and also validation. But already the data we are minimizing 70-30 for training and testing. So how many parts we will make? Then validation is a problem. If it is not validated properly, generalization is failing. That is where we take something called cross-fold validation. Okay, so what we do here, we are folding the data into parts. That means now I folded into 5 parts. I will train with 4. 1 I use for validation. Okay, yeah. Yeah, see, both are same, but you are using the same data for when you're doing testing. After training, you're testing. But every time it is training, you need to validate it. Okay, see, every time I'm testing, I'm validating. Okay, training, I'm validating it. So here we are validating. So cross validation with number of folds. So you can decide like 5 folds, or you can decide 7 folds, whatever. So one of the fold will be for validation. Next time, it will take this for validation. And next time, it will take this for validation. See, now you are validating data, using the same data, you're creating folds and showing as if it is, big workout. Okay. So it's a big concept. So I'm simplifying it. No worries. Then I'm going for logistic regression. Look at it. The entire logistic regression is, that's it. So machine learning is very easy to learn. So don't hate machine learning. It's very easy. But what is hard? If machine learning is easy, what is the hard part? Learning machine learning is very easy. What is the hard part? Mastering is hard. Okay, learning is easy. That's why 90% of the people will learn machine learning just like that. But if you want to master it, you need to know everything about. That's why I always joke to my students. You can be a cook or you can be a chef. Whoever working in the kitchen is a chef? No. So your mom, is she a cook or a chef? Cook or chef? Cook. So she's not chef. If she is not chef, what is the difference between chef and cook? Presentation, only presentation? No. Yeah, mastering that. Okay, this guy knows about food and also about all ingredients, how they interact with each other. Okay, flavors, taste, what should go first, this all. There is a creation, there is engineering. Okay, all those things goes. They know if you are if you say that I am diabetic, immediately he will change the menu. If you say that I have this problem, immediately I change the menu. So everything, you're a Chinese, Western. So he understands the ingredients and the interplay between them. There is no limitation for the chef, but the cook, there is a limitation. So they are good with some things only. So knowing the ingredients, the process, the heat, the temperature, all those things, how the food interplays, that is what makes a chef. That with a lot of experimentation, lot of professionalism, lot of practice. Your mom can cook in the night. When you wake up, she will cook. That is same thing routinely doing it. But here, it is every dish is special. That's why dish quantity will be less, price will be more, because the expert is doing. So that's why you need to be a chef. Okay, chef knows about each and every parameter in the data. Okay, without that, the ingredients will not come good. The ingredients won't play. When the ingredients won't play well, the accuracy will be low. If your model is getting low accuracy, I mean, don't always suspect that, this area. Maybe data is not good. The variability in the data is not good. Data variability is also very important. If I'm giving only one section of student data, and asked to predict whether the other students will pass or fail, you can't predict. I'm giving all the pass students, all the bright students. Then if I give the data, so variability in the data. What is good data in this scenario? I want right from the failed students to the toppers. If the variability is good, then my model will learn better how students are behaving. You understand the variability in the data? So that is how you need to do that. Okay, so let's go to logistic regression. What is a logistic regression? It is sigmoid function and a linear. Okay, linear model and a sigmoid function. So it is for classification. What is our problem statement? It is also a classification, load or no load. So I am going to consider only those algorithms that are using classification. But this is a binary classification. Binary. Only two outputs, 1 and 0. Okay. Online, are you there with me? Okay. Oh, okay. I think I answered validation. Okay. Online. I think, are you there or everyone is shy? Okay. Yes. Thanks, Pooja. You will get a chocolate if you are here on. We have chocolates here. Okay. You are the only one who is Triveni. Triveni, you too. Okay. So at least we know that somebody is there. Okay. One more chocolate. Pawan, you will also get chocolate. Enough. I lost enough chocolates. Okay. So we have, now I don't want responses. Everybody respond. Everybody goes with chocolate. Yeah. So look at, I am going with a linear model. How can a logistic regression be a linear model? That is a classifier. How can a classifier become a linear model? Yes. So we have a linear model, and with the probability, we do that. So there is a decision boundary beyond which everything will fall into one line. Beyond, below that, everything will fall into other line. So we have a sigmoid function. 1 by e to the power of minus y. What is this y? It is nothing but the y hat. That means if I need to write a simple linear regression, if I'm considering, okay, beta naught plus beta 1x. I know many of you got scared when I wrote this equation, but don't worry. You don't need to learn this equation. But if you learn 20 lakhs, 30 lakhs package. If you don't learn, 10 lakhs package. Now you decide. Okay. So this is, we won't do mathematically. But somebody asks what is happening, what is the sigmoid function? At least you should know. Okay, good. So we have this logistic regression messages. Remember to have math knowledge to code. Is important. Yeah, see, you need math even to survive in this world. If you go to the shop and buy item and they say 20% discount, immediately what you use? Math. Okay? If anything you do in the world, math invokes logical thinking. Math invokes logical thinking. That is why I have a favorite statement. Even though you want to be a doctor, even though you want to be actor or a lawyer or a account, whatever, they will force you to learn math until 10th. Okay? They will force you, because without math, your brain will not be used 100%. Of course, you use only 6%, 7%, but that 100% of the 6% you won't understand. So that is why they invoke math. Without math, no logical thinking. So that is why don't hate math. But how much math? That is the question. The right question is, Pooja, how much math? To understand the algorithm, you don't need math. To drive a car, you don't need to be a mechanical engineer. Okay? But you want to repair a car, you're going on the road and tire change, all those things you need to be. This is my favorite statement. Okay? So how much math depends upon how much deep you want to go. This math, what I'm teaching, right, is very fixed math, easy math. So don't worry. Once or twice you go through, it will understand. But the moment you open the math book, you will feel yawning. Okay? Even the moment I say machine learning, most of them yawned. Okay? People are like that because we have these pre-assumptions that, oh, it is tough. The moment you think something is tough, it will be tough. Okay? That's like that. Don't worry. It is very simple math. Okay? Not big math, not PhD math. But to understand the model, to understand how it is working, you need basic mathematics. And believe me, promise that mathematics is 10th math. I won't go beyond 10th math. So that means I'm only recapping it. Okay? Don't worry. To use models, what is website integration? We are going a bit away from that, Pooja. Let's stick to the topic and I will come back. Okay, good, good. So here I am linear model. I am, importing logistic regression and creating an object here, logistic regression, and I'm giving to the model classify. Classify already I defined here. Somewhere I defined. Where did I? Yeah. So model and X and Y, and cross validation I'm doing for everything. Okay, where is my, yeah. So model LR, this model I'm passing on arguments, 3 arguments I'm passing, and there it will take the model X and Y, and then it will run the cross validation it will do, and accuracy it will. So when it is returning, we are getting what? 79.5, 79.45 or 79.5 we are getting, and cross validation is 78.8. Okay, good. This is fine, fair enough. But I want to also try decision classifier. Actually, you look at the data distribution and all and decide on the algorithm to use. But here, I just want to show that the same model, same data, how it functions on other things. So decision tree classifier, it's a classifier, and 70. Random forest, 78. By that standard, logical regression is doing good. This is a simple binary, and the data is not that skewed, and the distribution is good. Okay, that's why it is good. But if you go to the SVC, okay, support vector, so here 64. So that means sometimes big guns may not be good. Okay, good. So here we get 79.45 indicates model currently predicts the target variable approximately thus many times of the test data. So this is where the test data I'm going to use. Cross validation, okay, suggests that model generalizes. That is very important. You understand? Now cross validation is telling me that this model is generalizing well. Okay, on what? Unseen data. Unseen data, this is validation. Somebody asked. So I'm validating that your accuracy is that much. Accuracy is looking 79.5 and validation is 78. So now I am confident that even though my accuracy is high, validation could be low. Even though my accuracy is high, validation could be low. At least I am now fine that accuracy is good, validation. This much is fine because this is data, right? We're in the lab conditions. We are in the lab conditions. So it is saying that, so with this confidence, I can go into the market. Okay. In the machine learning and all, sometimes, not every time, sometimes 79, 80 is also a good thing because the starting value, you just found a problem. You gave me data. I started 80% accuracy. Good. Let's start. The more and more we use, the more and more fresh data comes. My model increase accuracy and all increases. Okay. So don't think that only 80%. Okay. For that matter, during COVID time, the efficacy of the testing, okay, COVID tests was only 50%. Still we survived, right? But now the model, the prediction of COVID or no COVID, it is more than 90%. So that's how with the more and more data, even there is improvement. Cancer cell prediction. Initially, it used to be very wrong, very low. Nowadays, all predictions are happening using cancer cell, using machine learning. So that's how machine learning, the beauty is it improves performance over time, provided you give variety data and you have perpetuity. Okay. So decision tree classifier is that, but if you see cross validation is good. Okay. His model is less stable and slightly overfitting is happening. How can this be go? Okay. It is better than, but it is going towards high side. So there is slightly overfitting can happen. Okay. Overfitting. See, it is more than that. Okay. Here, 78 indicates random forest is moderately accurate in predicting. Okay. Moderately accurate. Cross validation, good generalization. See, it should not be overfitting also. I will check that also. See, sometimes accuracy is very good. Wow, accuracy of the model is very good. You need to be careful. Is it overfitting? What is overfitting? Suppose you have data like that. Okay, your model is doing a line like that. This is overfitting. Okay, if your same thing, spare my art. If my line is going like that, it is underfitting. If for the same line, if my line is, sorry, okay, wrong art, sorry. Then if my line goes like that, it is proper fitting. Okay. So if I do this, you will say too much. How can you bend so much? This is overfitting. This is underfitting. And this is proper. Because this line is a polynomial, but still it is addressing the variability properly. Okay. Don't worry. We'll teach slowly. One day you can't be machine learning. Okay. Machine learning engineer, one day you can't. But one day I'm throwing so much knowledge on you and still 24 of you are surviving. Maybe you are here for certificate or really love machine learning or like me. Why should I take credit also? Okay. So if you are for certificate, hang on. If you're really here for love of the subject, great. If you're here because you like my teaching, you're the best. What is? Except Puja, is ML part of full stack development? Okay, thanks, Pawan. What is that, Pawan? Okay, Pawan is running a parallel class. Okay, very good, Pawan. You should help each other like that. Machine learning is open source. Actually, we help each other. You know, there are some topics which I don't know. Then what will I do? I will look at my seniors and they will help me. Okay, senior guys who are big guys and all, they're working on big models and all. I read their papers and all and say, wow, you can do like that. So it's absolutely fine. We should help each other. There is nothing called my code or your code. It is all open source, our code. Okay. ML part of full stack development. Okay. Pooja, curious mind. I'll tell you like this. I have a Google application. I invented a new application called Google. Okay. Larry Page will be after me, but still, who cares? He's not in the group, so I can claim. Okay. So Google is having a website. Google is having a website. What is this? It's a text box. And this is what? A command button or a button. So who builds this? Full stack developer. Full stack developer. So full stack developer builds this. In the backend, there is a database. All those things full stack developer will build. That's just Google, silly, simple google.com. See, it's very simple. Okay. This is done by full stack guys. Okay, okay, I'm taking simple example. But the moment you type something and press this button, what happens? The magic happens. The most powerful AI model kicks in. The most powerful AI model kicks in. This goes as the input and generates output, which comes and presented on that data. See, the brain behind it is AI. Okay, so the body is full stack. So even if I'm using Uber application built by full stack developers, but when I ask to buy from point A to B, full stack will do all the things, but the price, depending upon the market demand, depending upon the traffic, depending upon the car availability, all these calculations, a bit of a second that will give you the car price, that is AI is doing. You understanding? So if I need to compare, AI is the body, brain. Body is full stack. Without body, there is no brain. Without brain, body is useless. Earlier, we used to have logic-based systems. Applications, when you ask 2 plus 3, it will give 5. Okay? It will give 5. Those are logic-based. Somebody is coding. If you ask 2 times 3, it won't answer because you did not code. Nobody code multiplication. So like that, full stack is also important. Without body, what the brain will do. But nowadays, you see all the companies are claiming we are AI, we are AI. What do you mean with that? They're stopping their applications? No. Application will be same. The model will be. See, even we have our dashboard. Okay. And we are working on some dashboards, okay, for clients. Those dashboards are AI. What do you mean by those dashboards are AI and this is non-AI dashboard? What is difference? Here, as the student learns, depending upon his performance or her performance, the questions will change, the learning material will change. Okay? If the student is learning at a low level content, that means it is being adaptive. It is learning your learning and it is suggesting. So like this, applications are same. Without full stack developer, who will build the applications? Who will maintain the databases? Who will give me the API call and all? But the brain can be logic based or the brain can be learning based. Here we are talking about AI based. Clear? My friend Pujita? Puja, sorry. Okay. Is not stable, na sir. Puja. Okay, who is that? Pavan. Okay, sorry. I thought Puja is asking. AI is not stable. What do you mean by not stable? AI is stable. Today I checked Google. In the morning it worked. In the evening it worked. So AI is stable. What I mean to say, AI learns. Today I was walking and fell down. I did not fall, but I'm saying tomorrow I may not. And day after tomorrow, I'll become more confident and may again may fall. Falling is not failing. Falling is part of learning. You understand? Falling is part of learning. So sometimes AI models misfire because that may be a unique kind of thing it got. That's why it may be low accuracy. Misfire means low accuracy. Okay. So that is not, we should not blame the AI. Okay. It is not. AI is stable. For that matter, any input is stable. Okay. Any input, if you give, output is stable. That is fixed logic. Here it is a learning one. So learning, there will be ups and downs. Learning will be ups and downs. So don't think that AI is not stable. AI is finding a new challenges, then it will slow down and then again improve. Okay, good, good. So let me complete my session. If not, we'll keep. Today is Saturday. You don't have life, but I have a colorful life. Okay, so let me complete my session. Okay, so you're all poor guys, no life. That's why you're here. Okay, no, I respect you. I'm just kidding. Okay, so random forest classifier. So here I'm having 78.37%, indicates the random forest model is moderately accurate, where the cross validation shows good generalization. So like this, I am doing. But surprisingly, support vector classifier is having a relatively low accuracy. Row accuracy. Okay, good. Yeah, In this scenario, under that circumstances, this is where I can say, Pawan, under the given circumstances, okay, under the given conditions, under the given data, logistic regression is good. We don't declare that logistic regression is good. Maybe if you change the data, everything may change. You understand, Pawan? It is not instability. It is about data, garbage in, garbage out. You give me more data, maybe SVC will be the better model over there. It depends upon data distributions, data availability, features, so many parameters. Good. Then what is hyperparameter tuning? I found out that logic regression is good, and I given this model to the customer. Customer is happy, but the model accuracy is coming down. So what I need to do? I need to do hyperparameter tuning. Or before handing over client to the client, I will do this hyperparameter tuning. So these are the parameters, okay, and I tune them. Good. Okay. So what is that? And for that matter, this is one of the students asked this question. Okay. Okay. Tell me, any one of you, if you answer chocolate. I don't have many, but I'll buy. Okay. He said that, sir, I'm running machine learning model. I am taking 70-30 ratio. 70-30 ratio. I'm running the machine learning model. First time I ran, it is 95%. I'm just giving some value. Second time I ran, it is 94%. Why? Every iteration or iteration, it is changing the accuracy. Why? But same data, same ratio. Sorry. Learning. No. This is X, this is Y. Same. Everything is same. Yeah, this is accuracy. End of the day, accuracy. We don't mind anything than accuracy. Accuracy is increasing and decreasing. What should I do? He asked me, so why it is happening? See, these kind of challenges will differentiate you between a good data scientist and a great data scientist. That's why you need to learn completely. Okay, somebody answered. Let me see if I lose chocolate or not. Data jumbles. Very good, Varun. Very good. Now you come and see me. The chocolate is waiting for you. Unless these guys start eating them. Okay, I leave one for you. Uses different algorithms. No, Triveni. Same algorithm. Same algorithm. Very good. That is what random. Randomness. How you pick the data is also important. How you pick the data is also important. Okay, because sometimes I pick from here, sometimes. That's why, again, silly example, when you want to taste my curry, will you take from the top and eat? What you will do? Why mixing? See, whatever machine learning I talk, it is all from the real life. Why you mix it? So that it is homogeneous. It is homogeneous. When it is homogeneous, then only you can sample it properly. If you take only sample from one portion, that may be all the tall guys, that may be all the smart students, that may be all the good data, but this may be the short guys, poor students. So your accuracy will be different. You understand? That is where randomness should be there. Okay, good. Nice. So I lost chocolate. Anyway, good loss. Okay. So parameter tuning I'm doing. So estimates I'm taking 60. Default it was 100. Default it was earlier it was, okay, where is this? Random forest, right? Default 100. So these all things it should be in your mind. Okay, 60. And then number of sample splits 5. Random state. So when I did that, it was 79.5. Okay, this is good. 72.9. Okay. Now I write. So always write your analysis. Most of you, budding data scientists, data machine learning engineers, you don't write your analysis. You always think, okay, and move on. No. Because the moment you move on and go on to other model, you will forget this. So every time you write nicely, take your time, no patience. We work on one model for 15-20 days. Okay, data is so simple, you're running and it's showing. 15-20 days it will take. Okay, so don't hurry because these all matter. So write down whatever observations, write down. So that when you revisit, you know what happened and what you did. Okay, good. So accuracy is that and that. Estimator of 60. Best performance with good balance between accuracy. Suddenly, tables turned. Suddenly, tables turned. Okay, here, tables turn, and we are saying that this is very good, 79.86. And SVC even improved a lot. You see, SVC improved a lot. RBF, linear model. Okay, so we use linear. Gamma is auto. Again, you bit of training, don't worry, don't get scared. Okay, so that's it. And confusion matrix. What is confusion matrix? Whenever there are two things in the real world, okay, two things happen, right? One is actual, one is predicted. So what shall man, actually it may rain, it may not rain. And I may say that it will rain, it will not rain. That's it. Right? Any classification, same thing, right? It is raining, and I said it will rain. Very good. It is not raining, and I'm saying that it won't rain. Or ulta. I said it won't rain, and it did not rain. But these two things are problem areas. This is true, negative, false negative, and false positive. Okay? Sorry, false positive and false negative. So in this is type 1 error. This is type 2 error. This is the alpha value. This is beta value. Significance of the test and power of the test. So that is how confusion matrix is very, very important. Confusion matrix is one more important part is the accuracy. Accuracy. How many times you predicted correct divided by the total. Accuracy. And there is also precision. So that means I can explain you like this. It's a big topic. So if you are playing this board game, when I will be winning or when I will be the best player, if every time I hit here, many times it can happen. I may hit at one point, but am I good? Yeah? No. This is winning. I'm consistently wrong. I am consistently wrong. Okay, but if I do this, I'm spreading everywhere. So these kind of things happen. So that is why we talk about precision, accuracy, sensitivity. All those things will come into picture. Okay, anyway, that to the course. Okay, when you learn, we will learn that. Okay, so confusion matrix. Did I do anything? No. Confusion matrix. Okay, I'm fitting and training, and I'm asking for the, give me the matrix and 31, 34, 4, and 6. So these are errors. Alpha is fine, beta is dangerous. So yeah, sometimes I may go wrong, but beta, the power of the test will be known. So that is how I have more accuracy, high accuracy. So wherever there is, I will focus on them. And I'm doing the fitment model LR, logistic regression. And for that, this is the data. So this is how we analyze the outcome. This is what we analyze the outcome. So conclusion is random forest classifier. It is well balanced predictions are there, okay, for both classes. But when it comes to here, again, linearly separable and effective dataset boundaries requires high computation resource. Always SVM requires high computation resource. But for that, I am getting a little bit accuracy. So I will go with maybe my random forest classifier. Okay. So very good. Okay. So my decision or recommendation is go with random forest classifier for this data. Okay. Because it is most robust, reliable for the data set and few errors, but better overall performance is good. So this is how we select few algorithms, work on them, hyperparameter tuning, okay, transformations, all these things we do and achieve it. That means if I build this model using the random forest classifier, okay, I can predict my loan status accurately 80% of the times. 80% of the 20% of the time, that's why we need humans still. That's why we need humans still, because model needs support. AI, it is not generalized AI. Now it is not general AI, okay, or advanced AI, okay. Still, machine and AI are working together. That's why whenever you're applying for home loan and all, if it is passed, it is failed, it's okay. But some cases, the branch manager will involve. Okay, that means AI can also do mistakes. AI can also do mistakes. That's what accuracy is talking. AI will never claim that I am 100% correct. If you are giving me some AI which is 100%, that means something wrong with the model. No model can be 100% accurate. Okay, no, good. So loan status, I can use random forest, and out of this, I will take few variables or features and use EDA, feature engineering, and directly I will use random forest classifier, and I will achieve my goal. Okay, guys, this is how I did this. Okay, great. How many hours? 2 hours. Exactly. Very good. Consistent. So precision. Okay, good. You can call your friends. Sometimes we call our friends consistently inconsistent. That means every time he will be late. That means he is consistent. In what? Inconsistency. So consistently inconsistent. Okay. Thanks for your time. I know this is very hard for you to bear, but any questions for me? That is common. Most of you won't ask any questions. But when I'm talking, when I'm teaching, some people will keep on talking. Okay, I don't know when those guys are having a private class there. Okay, so I'll be still around until you guys, figure out. Okay, Shweta, you want to say something?